Welcome. In this short video, we're going to cover 5 core concepts that help us understand what we're seeing under a microscope. These are magnification, resolution, contrast, field of view, and depth of field. Magnification is how many times larger an image appears compared to its actual size. So, for example, a 40x lens makes bacteria look 40 times bigger. Compound microscopes use multiple lenses, and their effects are multiplicative, so a 40x objective lens and a 10x ocular lens would make an object appear 400 times as large. Resolution is the ability to distinguish two close points as separate. Higher resolutions reveal finer details. Notice how the lower resolution image on the left looks blurry. This is because the points have to be farther apart before we can distinguish them. Contrast is the difference in light intensity in the darkest and brightest parts of an image, such as the background and a specimen. Stains or microscopy methods can boost contrast. An image can appear washed out if the darks are too bright. The image can appear dull if the brights are too dark. Field of view is the diameter of what you see. Higher magnification shrinks your viewing area. Consider this field of animals. You can see a lot of animals, but if we zoom in to count the spots on the giraffe, we can't see as many animals. Our field of view shrank. Depth of field is the thickness of the plane that stays in sharp focus. Images with infinite depth of field, as seen on the right, have everything crisply rendered, whereas those with shallow depth of field, as seen on the left, only keep a narrow slice sharp, blurring what's too close or too far. On a microscope, turning the coarse or fine focus knobs raises or lowers the stage, moving the specimen through that focal plane. Since most samples are transparent, you're effectively slicing through the sample in the third dimension. As you swap to higher power objectives, magnifying the image, depth of field shrinks dramatically, so at higher magnification, you should only use the fine focus to avoid moving the specimen far away from your fragile slice of focus, and risking contact between the slide and lens. Understanding these 5 fundamental principles of microscopy can help us to make sense of what we're looking at under the microscope. I invite you to consider them the next time you look through a microscope.